Have you ever been in the situation where you write a Solana program and then you come to an error case and you need to return an error, but you don't know which one is the correct one? Welcome to the club. This happens to me a lot of times. So today we're gonna learn about program errors. And with that, hello and welcome to another Solana tutorial. We have talked about errors before, but that was very broad with all the Solana errors. Today we narrow it down to just the program errors. So just what your program could return, and therefore what an instruction would error with. We're not going to worry about transaction errors or any other kind of errors, just the program errors. And I really want to have an understanding for each of them what they should be used for. Because obviously you can use them as you want. You can't just return that error code. But in order for programs to be somewhat consistent and also for app developers to understand what's really happening here, it would be nice if we would only return them in the specific error case that they were made for. So for that, we need to understand the specific error cases that they were made for. And because I didn't find any proper documentation on it, we're gonna dig through source code today. And I'm gonna have timestamps for each of the errors. You can just go to the one that you're currently very interested in and see what it's used for. But before we get to the individual errors, I need to get you on the same page of what we're talking about here. So let's start coding. I'm just gonna create a simple Solana program. So I'm gonna cargo init. I should have initted the lib. Yeah, too late. And I'm gonna cargo add Solana program entry point. I hope that's the right one. It is a crate. Great. What else do I need? The one thing that we're actually gonna have a look at today, which is Solana errors. Nope. Solana program error. Solana program. There. Solana program error. That's the one. That's what we want to have a look at today. So, simple program. Oh, Solana program has an example. I'm gonna borrow this. And that's gonna be our program, the librs, which I should move into source. And we don't need a main. And we need to tell you that you're this lib. And then we will need things. For instance, Solana account info. I can just add that. Wonderful. It even changed the underscores to dashes. I love it. Solana message. I guess you can, it's not like I really need them, but I'm gonna import them anyway. And Solana pub key, we have learned that we shouldn't use this anymore, but instead use Solana address. We're also gonna add that, and this should have an address, which we will use here. And that will totally work, right? I hope so. Okay, then we could specify this no entry point. On the other hand, I will only use it with an entry point, and I'm not intending to have this an actual library, so I can just remove that. Or we reiterate what we did in the previous video and add the no entry point as a feature. And this feature needs no other features. There we go. Then this works. And like this, hopefully I can compile my program already. Let's try. The classic. Don't ask me why I need this, but here you go. There we go. Perfect. I can build it. Still get warnings, but I'm gonna ignore those because all I want to do really is throw an error. Well, return an error. Can I get a smirk emoji? Looks great. I mean, setting bad examples, don't log emojis, but unless you're doing it for, I don't know, entertainment purposes. Right, so let's return an error, either by saying return error, or like here with the OK, I can also just be like error. And then I need a program error. And those are the ones that we're gonna have a look at today. All those program errors. These things here, and I'm gonna define that up here to use Solana program error, that I can just be like program error, and then I have all the individual errors. Let's start with the most trivial one, or the most obvious one, or whatever, the custom program error, which takes a U32, and I'm just gonna give you this number. Oops, there you go. This is a custom error, and custom I can use for my things, basically. Whenever it's a program error that is specific to that program, we use custom. So we can always use custom and define whatever we want here. Custom is pretty safe because it just means, well, this error is specific to the program. Ideally, there would be an enum defining which error code here means what exactly, but that's how you have the most freedom essentially. With errors, you can use any kind of error code here and you'll be fine. Just to demonstrate this, let's build this program again. And then, do I want a specific program ID? Yeah, ND5. Yay. And then my error program, which I will copy program to target, deploy the key pair, and then I will Solana config set myself to devnet and use the ND key, airdrop myself a sol. Oof, account doesn't have enough sol to perform the operation. What? Did the devnet faucet run out of sol? And now I have a rate limit. Oh yeah, great. First you don't have enough sol and then I get rate limited. Ugh, there we go. Here I have 2 sol. Gonna airdrop myself from a different wallet then. Fine. Okay, so now that I have sol, great, we can do stuff. For instance, we can Solana program deploy this deployable program. Here we go. 11 transactions, it's a small program, and the error program is deployed. Great, let's call it on devnet with this key. And we're gonna get types node for the file system stuff and Solana kit. And then, yes, we can specify our program address. I'm just gonna hard code this in here. We saw earlier that's what it is. And that's all I do. I don't put any accounts or any data. You just call that program. Let's go and see what happens. Oh, we got an error. What a coincidence. We got custom program error 0x0 and we're getting nice pre and post balances here. That's new. And we don't send the transaction because I say, well, if the simulation fails, we don't continue. So screw the simulation and skip the pre-flight checks. Or actually, I like the simulation. You can print that. But also skip the pre-flight checks and send the transaction anyway. Because that way I can then also look at it in a block explorer, see that we have a failing transaction because we get a program error. Instruction 1 failed. So here we have a custom program error 0x0. Why? Well, because that's what our program does. It returns a custom program error in this result. It's an error custom. And this doesn't really mean much. 0x0 can mean anything. It's specific for my program. Whatever I decide that this error means is what that error means. So that's program specific. In my program, it will mean something else than in your program or in the system program, for instance. 0x0 for the system program does have a meaning because the system program defines that as account already in use. Or 0x1 as insufficient lamperts. That's what the system program does. So again, custom program errors on the system program are again a different topic. But yeah, my whole point is custom we can use when we don't know what else to use. So that's our fallback. If we don't have a other proper program error, then we can use custom. Or if we want to have a specific version of a certain error, then use custom to really say exactly what it is. But this is not really the topic of today. I'm pointing it out because also a custom error is a program error. But really what I want to have a look at today is all the other program errors. So let's have a closer look. So let's look at the Solana Program Error crate. It lives here in the Solana SDK under errors. No, under where? Oh, program error maybe? Program error here. That's what we want to have a look at. That's all the program errors and we will have a look at them. In order to do so, I'm just going to clone this entire repository. Clone it. And then we open this. And also open program error. Here you go. Those are all the program errors. We already had a look at the custom, and custom will come with an error code. So any custom error also has an additional error code to, the error codes that we use here. That's the real enum. So this will be 0, this will be 1, and so on. They're mapped to strings. Can map them from others. Yeah, nothing super interesting in here. Maybe the part where we write them to strings. For the custom program error, it just gives you the error code as hex formatted. And then we get the descriptions or the string representations of the individual errors, which can be helpful, but also even that is sometimes just confusing. So let's go through all of those errors. It's not that many. I mean, okay, it's a few, but hopefully most of them will be so self-explanatory that we don't need to spend much time on them. And we will see about that. So let's get started with invalid argument. Okay, I think I always want to do this in the way of what I think it is. That's how I want to get started. I want to say what I think that this error is, and then we look at the source and check if I'm right. So invalid argument, in my understanding, is there is something wrong with the instruction data. That's how I would translate that. An invalid argument is the instruction just doesn't like what you put as instruction data. So you put a wrong argument. Let's say, for instance, our program, it will use instruction data. It expects to read a U8 or whatever. So I can be like, if instruction data length is less than the 4 bytes I expect, then I return an invalid argument, because the argument here should be a U32. And then I can do input validation, like I read it, let the from little endian byte, instruction data 0 to 4, try into, and then I map the error to a program error invalid argument, which I can then return. And I don't need that. I think I can I remove that entire thing? No? Okay, so I need that. Can I call it underscore? Yes. Okay. It looks a bit ugly, but basically this try into I just need because what if we don't have 4 bytes here? And then I return the invalid argument. So we build and deploy this in 12 transactions. And then if we call that, oh, we panic. So I can't do instruction data 0 to 4 because we don't have that. Oh, because I'm stupid, that's why. Obviously, if we have less than 4, then we already return that error. And otherwise, we can get that input. That try into here. So let's, oh man, this is going to be a long video if I get so into detail here. There we go. But now we get the invalid program argument. And even if we were to provide 4 bytes of data, let's say we provide 4 bytes of data, then we should not get this error, but the custom program error. Yes, nice. This try into will only fail if what we get here isn't a U32. So if for some reason I define the length, let's say the first, or let's call it bytes. The first byte defines how many bytes I should read. So I would do 1 plus bytes. Cannot be indexed by, then use it as usize. Which is ugly. Why would you do that? I'm just doing it to demonstrate that also this part here works. So if I rebuild that, now I would need to even check that I have 5 bytes actually. So let's rebuild that again and use 5 bytes. So I get the invalid program argument because from the 0 bytes, I cannot make a U32. I would need to specify here, please use 4 bytes. Then it would work and give me my custom program error. But if I would say 5 bytes, then it would again not work. Or even because it panics, right? But if I put 3 bytes, then it should again give me the invalid argument, because with just 3 bytes, this try into will fail, and then I will map it also to invalid argument. So my understanding for when to use invalid argument is when the input data is for some reason wrong. So I'm expecting some different input than I'm getting. The deserialization of the input data doesn't work, or I'm expecting a different type, or it would result in, I don't know, a 0 value or whatever. Anything with the input data is not correct, I would return invalid argument. That's my guess. That's how I've been always using this error. I'm fairly certain about that as well. But still, let's look at the source code and see where that error really is used. So let's check this. Can I find references for that? System interface. I mean, my problem now, where would I even look? I would probably need to look in actual programs. But look, here it's also used an invalid argument from account info. Aha, interesting. So here they're also using it if the account info doesn't match. Deserializes this from account info. So also if you put in the wrong accounts, if I'm expecting a different account, we will also return invalid argument. So arguments is not just the instruction data, but also the accounts. Good to know. I would like to have a bigger Solana program that is Solana specific. Let's check the Solana program GitHub. What do we have here? We have the system program, we have token program, stake, the loaders. System program is definitely a good contender for having a look at it. I'm gonna clone that. Why is that just the IDL in here? Token program has the source code in here. Without the source, this is quite useless. Maybe system program hasn't been extracted yet and it still lives in Agave. Could be. Okay, fine. Let's look at the token program. Where are we here? Here we get an invalid argument if the value of a non-zero pub key is 0, then it's an invalid argument. So if we try to get an optional non-zero pub key and the option is sum, then it can't be zeroed. And if it were, then it would be an invalid argument. That's where also this invalid argument is used. But again, that comes from some kind of input data is wrong. There it is. This pot C option. Where else? Here we also see that, so it seems to be a common way to write this, to map the error and then say invalid argument. So if we can't parse it to a float value, here this input, the UI amount, that's for interest bearing tokens. If it's not sized, it's an invalid argument. So yeah, this one actually uses it a lot. I still love to see the source code of the system program. Is that still in Agave then? Programs, PPF loader, system, source. Yep, I guess that's still in here. Okay, fine, so I'll also clone this. That's a big repository though. My computer will not be happy with me. But maybe I just open a part of it. Maybe I just open programs, system. And in system, there we go. We already have this invalid argument here. I find it somewhere here. If the advanced nonce instruction is called and the account is not writable, advanced nonce account must be writable. So here again, it's an account that has an invalid state. No, not a state that is not writable, and then they also use the invalid argument. So if the account info is not what we expect, and that includes the signer or writable field, or actually for the signer maybe there's a better error, but for the writable they use the invalid argument. Here again for the initialize if it's not writable, or for the authorize if it's not writable. So basically whenever that account is not writable, we get invalid argument. Find it 4 times here. And then we find it in other programs as well. In the loader, yeah. On the system processor, that's also interesting. So here we are when we do a transfer, the from must not carry data. So that's a state thing now. If the account that we're transferring from has some weird state or some state that we don't expect, namely in this case, it has data. If the system program gets an account that it should transfer from, but that account has data, then it will give you an invalid argument error. So again, here it even checks the state of the account that is being provided as an argument. Then again, it's not writable. If it can't upgrade, it gets invalid. I think here we're in the tests, yeah. And that's all in the tests then. Okay, yeah, so we see, getting back to all of our errors, that the invalid argument is being used when either the instruction data or the accounts are something that we don't expect. For instance, if you would expect a certain sysva, but you get a different account there, then you can say that's an invalid argument. So that's what invalid argument is used for. Cool. First one, check. Only many more to go. Oh, hold on. There's wait. I should have read at least one line further to invalid instruction data. Let me guess what that does. Oh man. Well, obviously it's invalid instruction data that I was thinking about before, that you use when the actual data of the instruction is wrong. That makes so much more sense. Okay, so then let me first of all admit that I was wrong, and secondly change what this is being used for. Invalid argument is just for the accounts, and invalid instruction data is for the actual instruction data. So in my program, all of that stuff should actually be invalid instruction data, this and this. And only if we work with accounts, let's do if account 0 key. How do I get the sysvars again? Yeah, Solana sysvar. Let's say I wanted to have rents it. Why not? Although it can be loaded without passing sysvar ID. Okay, so that's a bad idea. But so can all of those. I think those are all the ones. That's in Solana Program sysvar, not in Solana. Is that a separate package, or is that just I need to have Solana Program? But if I don't want the entire Solana Program, okay, you'll get Solana Program. Here it has the instruction sysvar ID, and then I can use it as this. So let's say if my account key is not that, then I would return invalid argument. So argument seems to be for accounts or an account not being writable or whatever. So let's say the first one, second one should be my instruction sysvar and my first account is writable. If it's not, invalid argument. And if the instruction data is something that I don't expect, then I say invalid instruction data. But I think some programs are already confusing those, and maybe that's why the invalid argument, I think, also comes sometimes from the instruction data. So, I mean, it's not clear. The arguments provided to a program instruction were invalid, but you could argue that instruction data is also an argument. But then here, invalid instruction data, this is pretty clear, and instruction data's contents was invalid. So what's inside the instruction data is not what we expect. That's the invalid instruction data. So if we build and deploy this now, what? Again, did I kill my... It's still here. Oh, because I have Solana Program. No, screw this. Screw Solana Program. You don't use this. I wonder where instructions went if it's not in sysvar. Oh, there's the instruction sysvar, which is now a separate one. Okay, so cargo add instructions sysvar. Wow, okay. And then I can use instruction sysvar ID as the sysvar instructions. Okay, that's how you should do it. And then I can hopefully also build this. Okay, good. Okay, now build and deploy, run it. Then we get invalid instruction data because in our call we still have this. If we have valid instruction data like that, we will get, oh, we get a panic. Wait, what? Oh, because we don't have accounts. Yeah, I should have checked that. So we need to provide accounts, which is a list of accounts with the following address. I'm just gonna put a random address. Fine. What's wrong here? There we go. But if that's a read only, if I put twice that account and twice as read only, then that's still not gonna work. And now we get the invalid program argument because those arguments are wrong. To get them right, this one needs to be writable, and the second one actually needs to be a sysvar. And I'm too lazy to find it in the kit. Only then I get the custom program error again. As soon as that is, again, a different address, if that's a different address, we still get the invalid program argument because that's what we defined here. So invalid argument seems to be for accounts. Invalid instruction data seems to be for instruction data. Is that so? What would the system program say? Invalid instruction data. You don't have that at all. Where do we have that? Because process transaction, that's tests. Invalid instruction data. Yeah. So if instruction data can't be deserialized, then we get invalid instruction data. That makes sense. Otherwise, I don't see it a lot. Yeah, seems to be when we can't deserialize it properly. Decode instruction type. Oh, this is a clear one. Here it's pretty clear. If we want to try out what instruction is being called, so we read if there's anything in the input. So if we have any input data, and if not, if it's empty, we return the invalid instruction data. There it's quite clear. And else, it even uses a custom error, a token error for invalid instruction, because they want to be more specific than this is invalid instruction data. But it would also be fine if they here said invalid instruction data. Yeah, but they're more specific, which is cool. But that pretty much answers what this is used for. Also the name itself, that's so obvious. Invalid instruction data, that you can't really get that wrong, right? I mean, you can, instead of using that, still use another one accidentally. But there is this one for invalid instruction data. So if the instruction data is not what you expect, use this error. And instructions data contents was invalid. Contrary to the arguments provided to the program instruction were invalid, where the arguments are mainly the accounts. But I would also argue that instruction data is an argument. So I think this is what you would use for anything that got to do with instruction data. And then it gets also more specific for the invalid arguments or the accounts. and we'll get to this one in a second. So third in the row here is invalid account data. So now we're not talking about instruction data, but now we're talking about account data. So we have provided an account as an argument, but then what's written there is not what we expect. So the data contents was invalid. That could be something like if my account 0 data length is less than whatever I want to read, or is 0, then I could be like invalid account data. Do we need to demonstrate? If I call it now, I'm gonna get invalid account data for instruction. So also that should be fairly straightforward. It's the account data that we're not happy with. Similar to instruction data, but now about account data. So if you deserialize the account and you can't deserialize it because there's some other data there that you don't expect, then invalid account data is the right error to use. Let's see where our programs that we know use that error. Do they? Let's check for the token program, add extra account matters, mint data, fetch account data. And if that doesn't work, then we get invalid account data. Okay. Or if we calculate the account length and it's not the length we expect from the mint data length, then it's also invalid account data. So that's again the size of the data of this account that we're not happy with. Here the same, I think. Or no, here it's actually deserializing from. So account date we try to deserialize, and if that doesn't work, then it's also invalid account data. That's pretty cool. So yeah, 2 more examples for that. Those are already 2 good examples. And then maybe we find something for the system program as well. Yeah, but that's all just in tests. Let's find them all. That's in test, that's in test, that's in test. There. Yeah, classic. What are we doing? We do advanced nonce. And if the state is uninitialized, then we give an invalid account data. That's a different enum, Solana instruction error. Reasons the runtime might have to reject the instruction. Interesting. So instruction errors and program errors have an overlap. Let's quickly look at that because I'm currently a bit confused. We have program error and do we have, yeah, but there's also instruction error. Reasons the runtime might have rejected an instruction. Do they overlap with the program errors? Reasons the program may fail. Deprecated, use custom error instead. The program instruction returned an error. That looks pretty much like the same thing. No, it has more errors actually. And then there's also custom here. Call depth, like missing account. So there are more errors here why the runtime may say it failed, but that's not the same as a program error. It's just currently for the system program still an instruction error. So the system program still thinks it's runtime, but probably not for long anymore. They want to move it out. But as long as it's still part of Agave, yes, it is kind of part of the runtime. And that's why this here is an instruction error and not a program error. But I think it's used interchangeably. It has the error with the same name. And it raises that error if the state is uninitialized at a point where we expect the state to be initialized. So the obvious answer is invalid account data. And invalid argument was for when it wasn't writable. And then there are a bunch more that we will still have a look at. Okay, but coming back to here, the invalid account data should also be fairly self-explanatory and fairly clear when you should use that. When whatever's written in the account is not what you expect, either because it doesn't have enough data or the data is not what you expect. Then invalid account data. So account data too small. Oh, damn it! There's a separate one for this as well. Accounts data was too small. Well, shit. So really, and this is why this is so confusing. And I wouldn't say what we did here is wrong, just that the better error would be accounts data is too small. Although, is it though? It's a like, I don't even know. I don't even know when I'm supposed to use this versus that. This is so confusing, man. I tell you, both are probably fine, but what does it mean really? I wish the devs would have a proper, real definition of when to use what, because that definitely means what is there is wrong, and that can also be the size, actually, in my opinion. This one with the account data too small, maybe we just use that for, oh, we want to write to there, but we don't have enough data, kind of. Or is it also we expect to read from there, but the account doesn't have enough data? I don't know. Let's look it up. Let's try to answer that question, because an account's data was too small. I mean, come on. I mean, yeah, I would have guessed that from the name as well, but what does it really mean? An account's data that I wanted to write to, or an account's data that I wanted to read from? Where is that used and how is it used? Can I find that somewhere? Can I find all the references of this? Program runtime. The BPF loader will use it a bunch, like when it wants to write program data, but the data length is not enough for what it wants to write, then obviously it gives me an account data too small. Yeah, same here. So can't copy. If I try to copy over the program and it's not big enough, then account data too small also makes sense. The max data length is too small to hold buffer length, then it's another account too small. So, I mean, for the BPF loader, that makes sense, and it's always for writing there, as far as I can tell. Always talking about the buffer. Here we're in tests already. Okay, and the loader v4, probably the same. Write out of bounds. So it seems to always be... Oh, no, also here's a read out of bounds. Here, in the copy instruction, we also have a read out of bounds. So it's also for reading. Does the token program have that? Yeah, when it deserializes, I think. Removed bytes, previous account. If we try to remove more than we had, then also account data too small. Okay, so this seems to be more of a... Either we're resizing something, or we writing more bytes there, or we read at the point where the account just doesn't have enough data anymore, but the focus is on the account is being too small, not what is written there is not what we expect. Then we use the account data too small. However, for the account doesn't have any data at all, I do think that the invalid account data is what most programs use to actually indicate that. Like, I haven't actually gotten that error in the wild yet. Because it also sounds wrong. Account data too small for... No, actually, here I would actually argue that you would say the account data is invalid because you expect data to be there, and that's not the case. Account data too small, I would probably only use if I wanted to write some more data to an account that doesn't have enough data allocated. And even there, because you can allocate data on the fly and just say, oh, the length is now different, you have a kilobyte at additional account data if it's an account that your program owns. And you can just allocate that. So that's why we don't see that error much, I think. But it exists and it is being used, even if not a lot. But yeah, there's a slight distinction between, oh, I'm expecting something to be there, and, oh, I'm expecting it to have a different size. Because obviously there's also an overlap. I'm expecting something to be there, and in order for something to be there, it needs to have a certain size. So it's not clear. It depends what you want to say to the user or the app developer. Hey, make your account bigger for this to work, then use this one. So you don't expect any data to be there, but you expect data to be allocated or the account to have a certain size, then use this arrow. If it's, oh, I expect some data, some concrete data to be there, then use this one, invalid account data. Because even if you change the account size, if there's zeros there and you're not happy with it, then that's still invalid account data. So this is the one you would want to use. That's my argumentation now for how to distinguish between those. And with that, I think that's enough. Good enough on that. Moving on to insufficient funds. Also, that should be fairly self-explanatory. We don't have enough lamperts on our source account that we want to subtract lamperts from. And we need those lamperts though. So we don't have enough funds. Maybe we want to do a system program transfer to somewhere, or maybe it's our account and we want to just transfer the lamperts somewhere. Point is, we do not have enough lamperts. So in our case, we could do a if the account's 0 lamperts are less than 002 or whatever, insufficient funds. And if we do a system program transfer, then the system program will check for that. And the system program will return a custom program error though, if we don't have enough funds. We can use this one for indicating, hey, we would need that many lamperts, otherwise our instruction just doesn't work. Maybe we need it for rent or whatever it is. So in that case, I would now get an insufficient funds for instruction error. Token error. Token also has an insufficient funds. Yeah, but that's insufficient token funds that we're talking about here. And that then becomes a custom error. So that's something different. Also the system program. There you go. This one. In system instructions. It also returns insufficient funds on overflow, even though that's not insufficient, but too many funds. But that doesn't happen often, does it? Who has that much SOL on one account? Nobody. So that's a bit esoteric. But here we get insufficient funds if we're in withdraw and we're uninitialized and the lamperts we want to withdraw are bigger than the lamperts we have, then we have insufficient funds. So there's not enough on the account for what we want to withdraw, which comes from instruction data. And same here, insufficient funds if we're initialized, just that we remove what we need for rent exemption before as well, or whatever. Yeah. So yeah, that's pretty obvious when you do that, right? If you don't have enough lamperts, but you need more on the account, here for the withdrawal, could also be for paying for something else, I guess, then use insufficient funds. However, interestingly, the system program, let's check that in the processor. If it does a transfer, if the lampert it needs to transfer is more than what we have on the account, then we get an insufficient funds. But this is done a system error, result negative lamperts. That's the official name for that. And that's 1. I always then called it insufficient lamperts, so insufficient funds. The real name for this one, this is a custom program error of the system program now. This is all the custom errors of the system program. 0x0, account already in use. 0x1, result with negative lamperts. And then it also has an invalid program ID because every program needs that, I guess. Yeah, anyway, so here it then returns that custom program error and not the insufficient funds, just to confuse you. I don't know why, but that's how it's implemented. So that's how it is. Okay, but I'm fairly happy with understanding when to use this. So we can move on to the next one. Incorrect program ID. And holy moly, this one is one of the ones that just confuse me. Like, when do you really use that? See, my intuitive understanding would be you use that if, say, your program ID is wrong. So I would use that for, let's say I'm aware of my program ID. It's this one. Oh, I can't have the same name twice. If the program ID we read here, because in every execution we get to see our program ID, if that's not the same, then I would say incorrect program ID, which now would be fine. But let's say I expected it to have a different ID here. So when the program itself expects to be at a different address, I would return this error. And it would look like this. Wait, hold on. Oh, if it equals I error, classic. Classic, stupid me. Of course, if it doesn't equal, then I error. If it equals, everything is fine. There we go. And now it looks like this. Incorrect program ID for instruction. It's such a confusing name though. For instruction. So this instruction expects a different program ID, but I think it's made for accounts. Does Anchor return that? What error does Anchor return if you don't give it the correct program ID? Or if it's not deployed to that address where the program expects that it lives? Does it also give you that then? I'm not sure. Maybe that's where I have that from. Because from the text, what it says here is the account did not have the expected program ID. So that's an owner check, I guess. Incorrect program ID is the result of a failed owner check. But why does it not say anything about owner? Incorrect owner would be a much nicer error in that case. No? Did not have the expected program ID. When you say program ID, I'm not thinking of owner, I'm thinking of the executing program. So the account did not have the expected program ID. Is it the program account that we are executing that doesn't have the expected program ID? Then I'm doing it the right way now. Or is that really an owner check? incorrect program ID for an account that is not owned by the program, would you do something like, if my account owner doesn't equal my program ID, for instance, that then this is the correct error? What is it? Is it this or is it this? Or is it both? But it's talking specifically about accounts, so yeah, this is also an account. Like we also this here we get the account address of the program we're currently executing. Like what program was executed. It's also an account. Everything is an account. So yeah, this is just super confusing, this error. So let's look it up. Let's see where and how it's being used. Here it's not being used. But if we find all references, block store, lib, the BPF loader, program account get owner, not the program ID. Yeah, so it's an owner check. Again, an owner check. And here, process instruction. Oh, so that's a test. Yeah, so it seems to be for owner checks. This seems to be the error for owner checks, which is just really badly named, in my opinion. But it's good to know, because if you ever get that error, you know what it means. Incorrect program ID. Where is that being used? We check the owner. Yeah, there we go. So it's again an owner check. Where else? Create native mint. Check program account. Here we also use it for if the new program ID is the old program ID, update. So in that case, it's not an owner check, but also update when we process instruction, transfer hook instruction update. Transfer hook program ID. If that transfer hook program ID, that's the new program ID. If that's already the same as the program ID. Yeah, interesting. So it's not always a direct owner check. So yeah, it seems that this one is mainly a owner check failed error. Although I still imagine that Anchor throws that error if the program itself that I'm calling doesn't have the ID that it expects that it has. And maybe Anchor is misusing that, or somebody misinterpreted what it means. And maybe there is no better error, so we misuse it, or we use it for that purpose. But then the message is still a bit weird. The account did not have the expected program ID. Yeah, that really sounds like owner check failed. If my program ID here has a different address than what I expect, what would I then return? Certainly not a custom program error. And for the lack of better options, also this one. Okay, fine. I allow you to also use this one in that case. Yes, because I have the authority to decide this. Of course I do. Okay, anyway, moving on. This video is long already. To a simpler one, missing required signature. I think this is so obvious that it should be obvious. A signature was required but not found. In that sense, it makes sense that it's right after this one, because if this one is for owner checks, this one is for signature checks. So if, let's say, your account is not a signer, then you would say you're missing a signature. From a program perspective, this is how I would use that. Because we're talking program error. Within the program, I'm expecting a signature, but I didn't get one. And the only way how the program sees signatures is through this is signer flag from the account info. Because we're not actually reading signatures. We don't get that in the program. We're just getting the accounts and whether or not they signed. The signature verification, that's a step somewhere else. In the program, we just have this flag. So this is how I expect that to be used. And I'm gonna temporarily move that on top, such that if I build this and then run this, I get this error of, oh, yeah, it is a signer. That's true. Account 0, hold on. What am I putting? No, it can't be a signer. Hold on. Am I signing for this? The random address. You're writable, not a signer. I shouldn't sign for the random address. So why do I not get a missing signature? Ah, there we go. I do get a missing signature. Just didn't wait long enough. We get a missing required signature for instruction. Wonderful, because this guy didn't sign. And that's, I guess, what that's used for. Should we check? Upgrade authority did not sign. There you go, a signer check. Migration authority didn't sign. New authority didn't sign. Is instruction account signer. So this also just checks the is signer. We get that account index, otherwise we're missing that account. Is signer. That's what we're checking. Yeah. If it's not signer, we're missing a required signature. So that's quite obvious. That's a signer check. That's, yeah. Let's find all. In system, for instance, the system program, advanced nonce, the account must be a signer. So the authority must be a signer. Here, this account must sign. Here, the account authority again must sign. And in the processor, allocate, the to account must sign. So the account that is being allocated must sign, otherwise we have a missing signature. If we assign, then the address as well must sign. If we transfer, then the from must sign. The guy that we transfer from obviously must sign. So yeah, this is obvious, right? The missing required signature, this is an obvious one. I think we can move on. 2. Account already initialized. Interesting that also that is a program error, and then the system program will again use a custom program error for doing that, but okay, fine. Account already initialized. An initialize instruction was sent to an account that has already been initialized. So something like, I would say here invalid account data, or maybe let's do smaller than 8, account data too small. And then let's do init state BAU 32 or whatever from the account data. I need to borrow this. And then I can be like, if my init state is not 0 for uninitialized, then account already initialized. Something like that. The name again is pretty obvious. We expect an account to have zeros, basically nothing written there yet, but we find an account that has some data written, or some data written in a specific part of the data where we thought there should not be written anything yet or whatever. Then we would use that. Does the system program agree? Where do we find that? System program doesn't seem to have it, but the loader has it in the upgradable loader upgradable instruction. Buffer account already initialized, or program account already initialized. Oh no, we're testing. That's where we use those errors. Does the token program use that somewhere? Nope, token program doesn't use that at all. It's also an error that I rarely see actually. I often see the system program account already in use, so let me find that for you. For the create account, for instance, allocate and assign. We allocate there. The already in use, account already in use, that's the first one of the system errors. There. That's what the system program uses. It could as well use the program error that has the same name or the similar name. Account already initialized, account already in use, almost same name. But it sounds to me like those are the same things. This is also saying, hey, this account is already initialized. It has already been used. And maybe initialized in that sense is not the right word for the system program, because as soon as you transfer sol there or whatever, it is being initialized even though it wasn't initialized, but it is already being used. So yeah, I guess the wording makes sense and they use a different error here, whatever. We can come back to this one and be like, yeah, this one is used whenever we expected an uninitialized account, but we found an initialized account. Simple enough. The opposite of that is then probably the uninitialized account, where we expect an initialized account, but we found an uninitialized account. That should also be, that's also fairly obvious, eh? System program is not using that. Token program is using that. When we process a close account, so we're trying to close an account, but it's not a mint account and it's not a token account, then it's an uninitialized account and we don't like that, so we error with uninitialized account. Cool, makes sense. Where else? Uninitialized destination. Oh, that's in tests. Dude, either I need to make a part 2 of this video or I need to speed run through the rest. How many are there left? Oh man, so many. I think we're just gonna speed run through the rest, right? The difficult ones were already here. Now it should be smooth sailing. This one at least is very smooth sailing. Not enough account keys. That's so obvious that I'm fairly sure that I get it right. Not enough account keys is what I should have done here in the very beginning before I do anything with the accounts. That if accounts length is less than 2, in my case, I would error with not enough account keys. This, by the way, is also the error that is returned if we use the iterator and then get the next account. In account info? Yeah, account info has a next account info. And that also returns the not enough account keys. So you use it like this, you get the iterator, and then you say next account. That's the cleaner way to do this. And it's basically just a wrapper that returns the not enough account keys if the iterator is empty, if I don't have the next account. So there I'm fairly sure, I'm actually super certain that that's what this error is used for. Let's just move on to the next one. Account borrow failed. Oh, that's interesting. I've also never seen this one. Failed to borrow a reference to account data already borrowed. That's very Rust specific. Maybe that happens when we're inside a CPI or something, or when you have the same account twice or something, but it's weird. What other things are there? Max seed length exceeded, invalid seeds, Bosch.io, account not rent exempt. You know what? I'm gonna skip a few that I don't see as super relevant right now, like this one, max seed length exceeded. They're more technical. Provided seeds do not result in a valid address. That's for PDAs if they don't have the right bump or whatever. Bosch.io error, okay. Account not rent exempt should also be fairly obvious. Not enough Lamberts for rent exemption. But I don't think that you need to, I mean you can, but you don't need to check for that because the runtime will check for that anyway, and then that error or a similar one will be thrown anyway, so I don't think you need to worry about that. Also unsupported sysvar. Sounds more like you're trying to get a sysvar that you can't get, but you should know it. Otherwise it's just an invalid argument again, because you expect to get the right sysvar. And then it gets interesting again. Illegal owner. Provided owner is not allowed. That is different to incorrect program ID. Illegal owner is when we try to set it to a different owner, but that's not allowed. When would we use that? Yeah, this is not really used anywhere here. Here? Interesting. That looks like a regular owner check. Metadata info, and if the metadata info account is not owned by the program ID, then it's illegal owner. Could it be that illegal owner is the new word or the new error for the incorrect program ID? Could it be that that's just a new name for that? Because this here certainly looks like an owner check, no? This is an owner check, and it says illegal owner, which makes sense because it uses the word owner, and illegal owner, not the right owner. You know, I would take that as a good name. The provided owner is not allowed. I don't know how I like that phrasing. Not allowed, yeah, whatever. I don't know. This is just confusing me now. Why do we have another one, illegal owner? I thought I can answer those questions by reading source code, but I cannot. Oh man. Ugh. Putting that aside, moving on for a second. Max account data allocation exceeded. That's obvious again. If we allocate more than the maximum, or allowed per transaction even. This also sounds more like a transaction error to me though. Why is that a program error? Why would a program want to throw this error? I mean that the transaction, the runtime does it for the transaction, yeah, I get it, but the program itself? Really? Which program ever throws this? Transaction accounts. Transaction context. Yeah, it makes sense here, but still, it doesn't need to be a program error. I don't know. Invalid data reallocation was invalid for whatever reason. Here they make sense. Also, max instruction trace length exceed. This is something the runtime can throw, not us, right? Me as a program developer, I don't think I wanna ever throw that error. Here it kind of gets a bit mushy. Why does this need to be a program error? And also, at the same time, like, for instance, call depth. Why is this not a program error then? Why is this one just an instruction error, which makes sense, but those ones need to be also program errors? I don't get it. Built-in programs must consume compute units. I mean, clearly this is not made for us anymore. This is such a specific error that you as a program developer don't use that because you're not building built-in programs. Don't ask me how that got into the program error, but it did, so whatever. And then here it gets interesting again. Very interesting. Invalid account owner. Isn't that the same thing as illegal owner? What's the difference here now? Invalid account owner. Now, is this what I would return it at an owner check? The system program has that. And the system program does that for an owner check. Are you kidding me? So the upgrade nonce account, if the owner of the nonce account is not the system program, we error with invalid account owner. But what about invalid program ID then? What was the other one called? Incorrect program ID. I'm gonna put a thing here and then I'm gonna search for this. Oh, that's not used anymore. Incorrect program ID. Maybe this is not used anymore. Hold on. Here it is still being used. Illegal owner is also being used. And what was the other one? Invalid account owner. Yeah, it also uses invalid account owner for validate registry owner. And this is clearly an owner check. And then incorrect authority is, well, you're expecting some different signer than you have. This is not like we're missing a signature. This is not an account missing that it's a signer, but the account that we got that is the signer does not correspond to what we have read as our authority. So some data account might tell us this is the authority that can do that, but then who signed for it as input arguments, we got a different authority basically. Then we would say incorrect authority, I guess. So that's again slightly different then. What else did I skip here now? Arithmetic overflow, that is fairly trivial as well, right? If you have an overflow from some calculation, you can throw that error. Immutable, an account is immutable. When is an account immutable? Well, if it's a program account, but also that I think, or if it's a system account or a system program or whatever, but also that I think is more the runtime would throw that, not so much we would throw that. I'm not sure though. Yeah, I don't know where that would be used. No, I don't see that being used anywhere. Okay, still this confuses me. Why do we have that now? Why is there an illegal owner, an invalid account owner, and the incorrect program ID? Okay, Andy from the future here. It feels like I cannot leave you without giving you the answer what the difference between those three errors is. The incorrect program ID versus the illegal owner versus the invalid account owner. I did ask this on the Stack Exchange and I did get a reply by John. I will link that discussion in the description below. I mean, I can also show you, but it's bright. We trust this guy. He's got a reputation. Also, he's an answer engineer. He knows what he's talking about. So, incorrect program ID is for when a different program ID was provided than what is expected. And as far as I understand this now, it's the wrong account being provided, kind of like the invalid argument, but specifically for a program ID. So say you're doing a CPI to the system program or whatever. So the system program ID must be one of your accounts. And if that's another program or another account that doesn't match the program ID you expect, then you would do this, as far as I understand this now. John says, for when an unexpected program is provided, for example, your program expected to receive the stake program, but got the token program. So in our little example, let's say we expect another account, the memo program, for instance. We get that account, and then we do a CPI. Where's the invoke? Where does it live? Solana program. Invoke, instruction, and account info. And the instruction has accounts data and program ID. Let's say accounts. We want to do an instruction to the memo program. Oh, it's a vector. Okay. Data. This is the memo if everything works. 2 bytes. And I think you need a vector here as well. And then now it gets interesting. The program ID. This, because we have the memo program, let's take the memo program key. But obviously this is only safe if we first check that the memo program that we get from this account actually is the memo program, because otherwise we call any program that the user gives us. So we do want to make sure that if the memo program key, if it's not the actual memo program ID, memo program v1, this is the memo program. And if that doesn't equal the actual memo program, then I return the incorrect program ID, like so. Oh, I still need to borrow this. Only that way, only if we actually check that, do I feel comfortable putting the key here. because otherwise we have the wrong program ID. We have an incorrect program ID for the program that we want to call. Thus, we throw the incorrect program ID as an error. And then I still need to provide the account infos. And for that, I'm just gonna clone account to, there we go, clone this. And here, expected an instruction. There you go. That's when I would use this error. Let's quickly test this as well. Deploy this real quick. So we gotta now call this with the memo program. Let's see if we can still make it work. Program will return an error. I'm gonna remove all of that stuff and just keep my custom error. And there we go. Program will return an error, and we do get our custom error, but the memo worked. This is if it works correctly. So that's the CPI worked. What if I were to provide the wrong program, like the token program? What happens then is I error with incorrect program ID for instruction. This is the right use of this error if the program ID we provide in the transaction is not what the program expects. And therefore, we throw an error. That's that. Now, coming back to what we had down here, in this case, I'm still not 100% sure, checking my own program ID, if that's incorrect, if I'm deployed to the wrong address. I think incorrect program ID is also the right thing to call. Although with this one, I'm not so sure. But yeah, it's like a CPI, but it's the most top level. So it's not a CPI. It's what you call as the program, and you're calling a program that doesn't expect to be called at that address. So that's why also incorrect program ID. I think that fits. And if I'm not completely mistaken, Anchor also does that. Anchor also says incorrect program ID. I could quickly test that. So this is where I'm going to deploy it to, but then I'm going to tell itself that it has this address that it expects. And I'm going to build that again real quick. And then I'm going to deploy this. So we deploy to this address. And if I call that program, let's see. It has a custom program for that. Declared program ID mismatch. There's a custom program error. Damn it. Never mind then. Maybe that's new. So Anchor has a custom error for this. It feels like all the Anchor versions use the incorrect program ID, but maybe I was just wrong on that. Anyway, forget about that. So because I don't have better ideas, I would use this or a custom program error. Why not? Or you just don't check for this if you don't want to. Moving on to an actual owner check. So this is now checking if the assigned program to an account is a certain program. So the owner of an account is a certain program. For instance, I want to check that this account 1 is actually owned by my program. Here I don't use the incorrect program ID anymore. The right thing to use here, according to John, is actually invalid account owner. This is what we should be using. So we did get that right. For an actual owner check, we want to use invalid account owner. Invalid account owner, if the owner of an account is not what we expect. Invalid account owner. Okay, that's what we use for owner checks. Great. But then what is illegal owner for? You might still be confused about that, as I was. This one should be used when we attempt to change the owner of an account, but the new owner would be invalid. Like the new owner is not a legal owner. Then it's illegal owner. This one is for when we change account ownership. So we provide a new owner, but the provided owner is not allowed. So it's an illegal, newly provided owner. So let's say after we check that it's our account, we would like to assign it to another program. But then we first check that that program is what we expect. And in this case, it's not an incorrect program ID because it's not the program we want to call, but it's the program we want to assign as the owner, therefore illegal owner. If we get another account, we could say new owner is the next one, account number 4. And then basically do the same thing, the new owner. Why not give it to the token program, whatever our use case is. And then if our new owner key doesn't equal the expected new owner, we say illegal owner before we do a system program assign or whatever. Likely means that the instruction is trying to change the owner, but that isn't allowed. I still don't fully get it, honestly. Could it be that the instruction is trying to change the owner, but the current owner is not allowed? The account is currently owned by something else? That could also be. Let's find this again. Here for instance, the token program does check that the supplied program ID is correct, and otherwise it gives incorrect program ID. When do we do that? Yeah, when we check the program ID, yeah, that's checking that the correct program is being called. Illegal owner, I don't see being used. I mean, here it uses that for a regular owner check again as well. It seems like there is confusion about this because it's sometimes being used as a regular owner check. And ChatGPT says something completely different again, where illegal owner is for checking an account if I own it, if the program owns it, and invalid account owner is for external checks, like I expect the account to be owned by a certain program, but it's not that. Still confusing. So I thought with asking a question on the Stack Exchange I can solve this. I'm still confused. So invalid account owner, we see some examples in the tests for the system program. Yeah, here again, account owner to invalid owner should return invalid account owner. So I don't come to a good conclusion here because there doesn't seem to be consensus about this, because some people just keep using the incorrect program ID for regular ownership checks, and that's official Solana stuff. That's Solana Foundation code. Others use the illegal owner. According to John, this is likely used when the owner is changed versus this being used for the actual owner check, and the incorrect program ID being used for when a provided program is wrong, which is not an owner, however. It's a program provided for being called, or the program itself, something like that. And the other two really talk about owners. Account owner, which happens to be a program, illegal owner for modifying, and this one for regular owner check. It's the best I understand it now, but really they can be used interchangeably because people don't stick to that convention. So expect that all three of them can be used for owner check. So I give up. There is no clear answer on this. Back to me from the past. We went through a bunch of errors and we understand them better now. And at least we know which errors there are now for program error, even though some I don't think should actually be program errors. They should be more like instruction errors or runtime errors or whatever that you as a dev can ignore. But yeah, a few of those program errors will come up regularly, like an invalid account owner, or not enough account keys, or missing signatures. Those are the ones where I would highly recommend that you use those instead of creating a custom program error. Also for invalid account data, invalid argument, invalid instruction data, use those. Unless you want to be more specific and say what exactly is the invalid instruction data, or what argument is incorrect or invalid. It's good to have a look at that and to try to understand more and more, not just from the perspective of I want to write a program and use the right errors, but also from the perspective of, oh, other programs give a certain error, what could that mean? And from that perspective, I think we did learn a bunch today, because we saw other programs and what they return in which case, so you can make more informed decisions when debugging, when you encounter those errors. And for most of them, I know which ones to use. For most of them. Just not the owner checks, because they still seem confusing. See you next time! Until then, you can watch those videos, give this one a like if you still enjoyed it, subscribe if you haven't already, and I will see you in the next video. Talking about Solana program development, because that's what I like to do, with the correct errors. Yes, 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 yes.